Good morning. I thought I would do another puzzle. This is Dutch Logic Masters. They post a lot of, I'm sure my most recent videos have all featured this site. It's where I've been getting my puzzles recently. They feature like some great Sudokus. Yes, I did Chased by Ghosts a couple of days ago, although I didn't make a video out of it. This was a fun one. It was like a variant Sudoku. It was 10 by 10 with a rebus, and you get to figure out where Pac-Man and the ghosts go. But I thought I would do another puzzle, so let's look at the new ones. Knights and Bishops in the Fog. It's attractive because it's a 2-star, but I haven't really been super enticed by these Fog of War puzzles. So I don't think I'm going to do that one. Ooh. Do I want to do the Dutch Flatmates diagonal X sums? I screamed ooh very loud. I've done so many of these Dutch Flatmate puzzles. Maybe what I should do is this other 2-star. It's a numbers game. As soon as we get past 2-star, the videos become very long, and I may need to break up the puzzle into separate settings or something like that. But let's do this one. It's a numbers game by Will Power. I've just done so many of the Dutch Flatmates' videos that maybe it's time to switch it up just a little bit. Anyway, it's a numbers game by Will Power. I have played some of Will's puzzles before, although I'm not sure that that's his real name. I think it's a pun, like Will Power. This one is 14 hours old, so it's a brand new puzzle, and it only has 129 solvers. I wonder if we will be the 130th or something else will happen. We'll see. So this looks fun. It's a numbers game. I like numbers. 4, that's a great number. 4 is 2 times 2, 2 plus 2, and 2 up to the 2. But enough joking. Let's read the rules. Normal Sudoku rules apply. Arrows, numbers on an arrow sum to the number in the arrow's circle. Numbers may repeat on arrows if other rules allow. There are 3 shapes formed by the arrows representing the numbers 1, 7, and 8. Circles in the same shape as one another have the same number. Circles in the same shape as one another have the same number. Okay. Kropke pairs. Numbers with a white dot between them are consecutive. Numbers with a black dot in between them are in a ratio of 2 to 1. Not all possible dots are given. Great. So this is going to be a fun puzzle, I think. I can go over the rules on the board. We're given these arrows in these circles, but they're in these kind of fun configurations. Like this is in the same configuration as this. These are both meant to represent the number 7, I think, and these are meant to represent the number 1 because they look like a 1. And then these are meant to represent the number 8. So we have 3 styles of arrows, the 8 arrows, the 7 arrows, and the 1 arrows. And circles in the same shape as one another have the same number. So what that means is that this cell is definitely the same number as this cell, is definitely the same number as this cell, which is definitely the same number as this cell. This is definitely the same as this, and this is definitely the same as this. I don't know where I want to start, but maybe I should just start by filling in colors or something so that I could think about the circles. See, these are all the same number. What I've labeled here is red because they're all in the arrows that look like 1s. These are definitely the same number because they're all in the arrows that look like 7s. And then the yellow are the 8s. But that's interesting. It's interesting because they definitely need to be unique. You see that because of the fact that these 3 appear in the same column, we know that whatever is in the center of the 8 is definitely different than what's ever in the center of the 1. It's definitely different than what's ever in the center of the blue. The blue is the 7, so that I can use some consistent wording. With arrows, sometimes it's helpful to think about the long arrows first. See, this here, you know, if this was a 9, we could sum to 9 with 4 and 5, or 6 and 3. There's a lot of different variations if this was a 9, but this could even be a 3. And then we could have 1 and 2 here, or something like that. There's so many numbers that could go within these short linear arrows. There's so many combinations that it might make sense to start with the longer ones, especially because of the fact that they have these Kropke dots on them. 4 minutes into the puzzle, I might as well start thinking about it. But how? I know that this, for example, can't be a 1. Also can't be a 9. Can't be a 1 because the white dots signify consecutive numbers. So if this was a 1, we would need this cell and this cell to both be a 2, and that would cause a contradiction. So this is actually in the middle of a consecutive pair. This could be like a 2, and then we would have 1, 2, 3, or something like that. Or maybe we go down here and we look at this one with the black dots. Black dots separate cells that are in a ratio of 2 to 1. So what we could have here is we could have something like, this could be a 6 and this could be a 3. It's because 3 times 2 is 6. The big problem with that is that the sum of these 3 numbers need to add to this one, which means that this isn't allowed. 6 and 3 isn't allowed because this adds to 9. This could be a 1. We would need to put a number at least 10 or greater in the circle, and we need to use the numbers 1 through 9. So we can't have a 6 and 3 here. We also can't have a 4 and 8. That's another way we could make digits in a ratio of 2 to 1. We could have 4 times 2 is 8. But that would also violate, we wouldn't be able to put anything in the circle. So I think what that means is that there's only a couple of options for what go around these cells here. We could either have a 1 and a 2, or a 2 and a 4. The same is true up here. And I think they must contain a 2 now that I think about it. Now that I think about it, this could either be 1 and 2, or it could be 2 and 4. This could also either be 1 and 2, or 2 and 4. In both cases, we need a 2. We need a 2 somewhere here. We need a 2 somewhere here. That would tell us that we're not allowed to have a 2 in this column. I don't know if that's so profound. I guess we couldn't put a 1 here. If we put a 1 here, then we would need a 2 in this cell and in this cell, but we need a 2 down here someplace. So you're not allowed to be a 1. You can only be a 2 or a 4. If you're a 4, then this needs to be a 2. If you're a 2, then this could be anything. Let's see, we could have a 4 here, and then an 8 here, and then a 2 here. We could then have a 2 here, and a 1 here, or a 2 here and a 4 here. But I think it all kind of works out. It's interesting, though. Let's see, what did we say? This is either a 1, 2, and a 4. We could have a 1 here, 2 here, 4 here. Or we could have a 4, and that would make this an 8, and this a 2. 4, 2, 1. Yeah, I wonder what this cell has to be here. Who knows? Maybe that's not the place to start, but I do think we've done some learning about these. I wonder if we're going to need a 4 on the line in one of these cases. That would become pretty restrictive to this cell. It would need to be a 7, 8, or 9. It'd actually be pretty funny if it was an 8. It's in an 8, you know? Both of these 8s would require 8s. Let's do some thinking. If this was a 2, what would we need? We need this to be a 2. This could then be a 1 or a 4. Not sure where I'm going with that. This cell here needs to be a 1, 2, a 4, or an 8. That's certainly true. That is certainly true. I want to force a 4 onto the arrows, but I'm not quite sure yet how to do it. Just try something. If this was a 1 and this was a 2, this would be a 4. Then we would need a 1 here and a 2 here. This would be a situation in which we don't have a 4 on the arrow at all. 1, 2. So this is an option. This is a valid way of solving these 5 squares. That's what happens when this is a 1. What about if this is a 2? If this is a 2, then this needs to be a 4 and this needs to be an 8. Now, this needs to be a 2. And this would either be a 1 or a 4, both of which would be allowed. Yeah, I guess maybe we're not going to get as much as we thought. We could have the 4, 8 situation. This is a 4 and 8, then this needs to be a 2. Yeah. Actually, I think if this is a 4, it's all sort of spelled out for us. If this is a 4, this is the last option. Then this would need to be a 2, and this would need to be a 1. Then we would put a 4 here and a 2 here. So in this situation, what we have is 4s in both rows. It seems like there's many different ways in which these 5 cells can work together. And one of those ways is just to use 1 and 2 on both of them. This could then be a 3. So that means that the minimum digit for this is 6. And the deal with that is that we didn't learn anything. If you have an arrow where the digits need to be unique, such as this arrow, these digits here need to be unique because they appear in the same region, and you have 3 of them, then the minimum possible sum we could get is 6. This can be a 6, a 7, an 8, or a 9. And we could then say, oh, we learned this needs to be a 6, 7, 8, or 9. This now needs to be a 6, 7, 8, or 9, but we could have derived that up here just using the fact that these 3 numbers need to be unique. So maybe we shouldn't have started with the black Krotke pairs. It would be, maybe I should have started with the white Krotke pairs. Another thing I could have done is just tried to use our color scheme a little bit. Maybe I'll try to use the colors a little bit, and then I'll get back to these Krotke dots. What I'm thinking is that in this region, we need a red cell. We already have a red cell in this column and in this column. Red is the color we've just arbitrarily defined to be the node on the one arrow. but it also can't be in this cell. What this means is that one of these two cells needs to be red. And I wonder if we can somehow prove to ourselves that the red cells can't be on an arrow. See, can this be a red cell? The minimum value of a red cell is 3 because of the fact that the red cells are certainly the minimum value of a red cell is 3. So is it possible for this to be red? You actually need to be less than 3 now that I think about it. What happens when you're 4 is that on one side we're going to get a 5, and on the other side we're going to get a 3 because of the Krotke dots, the white Krotke dots. And this is going to create a sum to 9, and now we've broken the yellow circle. There's nothing that can go in it. If this was a 1, we would need a 10 in the yellow circle, and 10's too big a number. So you actually need to be less than 3. You can only be the numbers 1, 2, and 3. But you also can't be 1. We know that already. We're 15 minutes in, 14 minutes in. I feel like we could have started up here and we would have been this position faster. Anyway, I wonder what happens when you're a 3. I wonder if that becomes a little bit restrictive. If you're a 3, you can only be a 2 or a 3, but if you're a 3, then on one side we're going to need a 2, and on the other side we're going to need a 4. I don't think it's possible for this to be a 4, because then we would need a 3 here. We would need consecutive numbers, and you know, a 5 would create a sum of 12, a 3 would create a sum of 10. So it's not possible to put a 4 here. We would need a 2 here, and a 4 would need to go here if this was a 3. Now, if this was a 1, then the sum along the arrows would be 6. But this sum is already bigger than 6, so we can't have a 1 here. We would need a 3 here. And now the sum of these numbers is 8. So then this would need to be 1, this would need to be an 8. Something like this. This is all we're just playing through the situation where a 3 is here. What would we know in this situation? Now we would need 3 numbers that add to 8. This one needs to be consecutive with 3 but can't be a 2. You would need to be a 4, and now just because of everything you would need to be a 1. And now you would need to be a 6 so that we have this. But this works. It's possible to put a 3 on the arrow. There's only one way of doing it, but it's possible. I wish we could go a bit further. Maybe we don't start with 3, but we start with 2, and what we realize is it's actually not possible to do 2, and I have an idea why it might not be possible. Let's put a 2 here and see what happens. Now we need a 1 on one side and a 3 on the other. If this was a 1, then this would need to be a 2. This would create a sum of 5, and we wouldn't be able to reach 5 because of the fact that these 3 numbers, which are all unique, need to sum to the number in the circle. The minimum sum of 3 unique numbers is 6, so we can't have 5 here, so you're not allowed to be a 1. You would need to be a 1. And now you would need to be a 3. And now, if you're a 4, that all seems allowed. We would get 9 here. You would then need to be a 6. If you're a 2, we would get 7 here. And then we would need a 4 here. That all seems allowed too. Well, I guess you can't be a 4. If you're a 4, then you need to be a 5. That breaks everything. You would need to be a 2, and now you would need to be a 1. The sum would then be 7, and you would need to be a 4. Now, to sum to 7, we would need a 4 here, and you would need to be a 1. Ah, There's our contradiction. You're not allowed to be a 2, because when you play through it with the 2, we get this contradiction here with the 1s. So what does that mean? That means you're not allowed to be a 2. You need to be a 3. And we just did this with the 3, I think. You're not allowed to be a 4. You need to be a 4. You need to be a 2. You need to be a 3 is, I think, what we established. Now you do need to be an 8. Now you need to be a 1. What else? You need to be a 4, and you need to be a 1. And then you need to be a 6. So we know it's an interesting way to get through the first 20 minutes of a puzzle, but we know that the number that is inside the 8 is an 8. You must certainly be an 8. And now I think we could play down here and figure out what needs to go down here. Is that how I want to do it, though, or do I want to approach this one? I'm not quite sure. Let's see. We know that one of these needs to be a 2. Could we have a 2 and a 4 down here? I don't think we could, because then the other missing number to sum to 8 would be a 2, and this would cause a contradiction. So you're no longer allowed to be the numbers 2 and 4. You need to be the numbers 2 and 1. That's what must go down here. And if you're 2 and 1, definitely, then you must certainly be a 5. Now, if you're a 5 to sum to 8, we also would need 2 and 1 up here. But the way of making that work is to put a 4 up here. So you need to be it needs to look like this. Okay. Can we keep going? I feel like we've learned a lot. It's becoming difficult to be a red cell. Maybe a 7 could go in the red cells, but what can't go in the red cells is 1, 2, 4, 8, 3. There's a lot of numbers that can't go in the red cells. It's becoming a bit difficult. Actually, I bet it's very difficult to be a red cell. Yeah. So what do we say is not allowed in the red cell? 1's not allowed in the red cell. Neither is 2. Neither is 3. Neither is 4. Is a 5 allowed in the red cell? A 5 isn't allowed in the red cell, I don't think, because to sum to 5, we can either use 1 and 4. We're not allowed to use a 1 on this line. Or we can use 2 and 3, and we're not allowed to use a 2 on this line. So you're actually not allowed to be a 5. Could you be a 6? We're going to determine that in a second. But we also know that you're not allowed to be an 8. And if you're not allowed to be an 8, then the only numbers that remain are 6, 7, and 9. Those are the only possibilities for the red cell. To make a 6, we can either sum the numbers 1 and 5, but we're not allowed to use a 1. We could sum the numbers 2 and 4, but we're not allowed to use a 2. Or we could sum the numbers 3 and 3, and this would cause a contradiction because we would have 2 3s in the same column. So actually, Mr. Red Cell is not allowed to be a 6 either. The only options left are 7 and 9. To make 7 with 2 numbers, we could do 1 and 2, or 1 and 6, not allowed because there's a 1. We could do 2 and 5, not allowed because there's a 2. And we could do 3 and 4. But if you look at these 2 rows, they both contain a 3. You wouldn't be allowed to contain a 3 at all. So you're not allowed even to be 7. You need to be a 9. In fact, all of the red cells, every one needs to be a 9. And now, how do we make 9? If we're not allowed to use 1, 2, or 3, we need to use 4 and 5. You're not allowed to be a 4, which means you need to be a 4. You need to be a 5. Now it's going to become difficult to be a blue cell. Tough. Tough, tough. Tough, tough to be a blue cell. How about this 9 down here? We need to sum to 9. We could do 1 and 8. That seems allowed, but we're not allowed to use 2 and 7. We're not allowed to use 3 and 6, and we're not allowed to use 4 and 5 because of these things. You need to be the numbers 1 and 8. The 1 needs to go here, and the 8 needs to go here. these ones? Is it going to be difficult to place these ones? Again, 1 and 8, it seems like it works. I can't do 2 and 7, there's a 2 here, and I can't do 3 and 6, there's a 3 here. I also can't do 4 and 5 because there's 2 4s that see these 2 cells. You need to be the numbers 1 and 8, but unfortunately we don't know the order that you appear in yet. Another way you could have done that is you could have said that there's a 1 and an 8 in these cells already. There needs to be a 1 and an 8 in this region. That 1 and 8 would need to appear in these 3 cells. That means either a 1 or an 8 needs to go on the line, and that pushes the other one onto the line too. So I think what that means is that we have figured out that these need to be a 1 and an 8, and we've derived that in 2 different ways. Now, maybe what we should do is move on to the blue cell. To move on to the blue cell, or I could think about trying to round out these down here. Maybe that's what I should do. You 2 need to add to 7. You need to add to 7 because you 3 need to add to 8 and you're a 1. So you need to add to 7. Why would it be difficult for you to add to 7? Question for the class, but I don't have the answer myself. I think it is relatively easy for you to add to 7. For you to add to 7, if you're not allowed to be a 1 or a 2, you could be a 3, you could be a 4, you could be a 5, you could be a 6. Well, actually, we could play through these. You're not allowed to be a 4 because there's a 4 in this region. You're actually not allowed to be a 4 anyway. If you were a 3, though, then you would need to be a 4. And now these would need to add to 8, but we already have a 2. You would need to be a 2, so we would have 4, 2, 2 would add to 8, but then 2 2s would see one another. So I don't actually think you're allowed to be a 3. I think you can only be a 5 or a 6. If you're a 5, then you need to be a 2, and you would need to be a 4. 5 creates the following situation. You need to be a 2 and you need to be a 4. A 6 would mean that this would need to be a 1, and now this would need to be a 5. So we certainly have a 5 in this column somewhere, but it's a bit variable. There's at least 2 options for what can go in here. Anyway, let's do what we should have done all along and think about our blue cells in the 7 shape. I wonder what goes in there. Well, what's not allowed to go in here? We can't have a 1 in there or a 2. We can't have a 3 either. We can't have a 3 in this cell because of the fact that to add to 3 we need 1 and 2 and there would be a contradiction. We also can't have 4 or 5. We could have a 6 or a 7, but not 8 or 9. You can only be a 6 or a 7. And now I wonder how that causes problems. It causes problems with the 6. To add to 6, we can either use 1 and 5 or 2 and 4. But those are the only 2 ways of adding to 6. They would both need to appear, and there's already a 1 in the region. This means we're not allowed to use 1 on the arrows, which means that you can't be a 6. The number in the shape of 7 just so happens to be a 7. So 7s are in the 7s, 8s are in the 8s, but a 9 is in the 1 circle. Fun. All right, we need to add to 7. We can do this in a whole bunch of different ways. We can do 1 and 6, we can do 2 and 5, or 4 and 3. Some bad news for us, though, is that we can't use the number 1 because of this one here. We can't use the number 1 in any of these, which means that we're not allowed to use 1 and 6. One of these combinations needs to be a 4 and a 3, but a 4 can't go on this line. This means that you guys up here, you definitely, you definitely are the numbers 4 and 3. And you guys down here, you're definitely the numbers 5 and 2. But we know that there's a 5 in this column, which means you need to be a 5, and now you need to be a 2. Whole bunch of progress. If you're a 2, then you need to be a 1, which means you need to be a 6, and you need to be a 5. And we have closed out our 8s. Awesome. Awesome possum. Cool. Can we figure out what goes in this 9? We need to add to 9 using 2 numbers. What are we not allowed to use? We're not allowed to use 4 and 5 because these both see a 5. Are we allowed to use 6 and 3? I believe we are. I don't see a problem yet. We're not allowed to use 7 and 2. And we're not allowed to use 8 and 1. There's a 7 here. Both these see a 7, and both of these see a 1. That means you need to be 6 and 3. You're a 6, which means you need to be a 6. And now you need to be a 3. And now you need to be a 4 so that you can be a 3. Cool. All right, again, we need to add to 7. Is this where I want to start? Maybe I should try filling in this square just because of how few numbers remain. We need to place a 7, an 8, and a 9 in this. You need to be a 9, you need to be a 7, and you need to be an 8. Gotten a bit of closure on this square. This has been a fun puzzle. Willpower. I've done some of your other ones. They're usually a treat. What else do we need in this column? Again, this column is pretty restricted. 1, 2, 4, 5. We're missing a 6 and a 3, but you can't be a 6. You need to be a 3. And now you, down here, you need to be a 6. All right, I think all that is left to do is to figure out this 7. Once we figure out this 7, what goes on these arrows, we will have exhausted all of the information in the puzzle, with the possible exception of this. But we'll have exhausted all of the information in the puzzle, and what that means is the remainder of the puzzle will be classic Sudoku. But we need to add to 7. How are we going to do that? Well, one way of adding to 7 is 4 and 3, but neither of these cells can be 4. Another way of adding to 7 is to use 2 and 5. We would need to put a 2 here and a 5 here, because this one can't be a 2. That seems like it's allowed. So this could be a 5. Oops, excuse me. This could be a 5 and this could be a 2. That seems like a way of adding to 7. We could also have 6 and 1, but neither of these are allowed to be a 1 because of these ones. That one here and this one here. Something like that. So what does that mean? That means you need to be a 5 and you need to be a 2. This arrow down here, neither of you are allowed to be a 1, so we can't use 6 and 1. Also, neither of you are allowed to be a 6, come to think about it. Neither of you can be a 3. You see a 3 and you see a 3, so you can't be 4 and 3. You need to be the numbers 5 and 2 also. And when it comes to 5 and 2, I think there's only one way of doing it. And we need to fill in this, but I think at this point we've actually exhausted all of the information in the puzzle, and what we can do with the remainder of our time, even though we're the ones keeping our own time or whatever, is do some classic Sudoku. So there needs to be a 7 in this region. That 7 can't appear in this row. It needs to appear here. You are our 7. And now what? There needs to be a 7 up here. That's not super profound. There needs to be some numbers in this column. That might be more helpful. Or in this column. That actually might be the most helpful thing to do. Because there needs to be a 1 in this column, and that 1 can't go down here. You need to be a 1, and now what goes down here is a 2. Okay, now in this column we're missing some numbers, but I could also just think about this region. I'm missing the number 3 in this region. That 3 needs to go out here. I'm missing the number 4 in this region. That 4 needs to go here. So one of you now needs to be a 3. 4, 5, 6. We're missing a 7 and an 8. But neither of you two can be an 8, so you need to be an 8. And now neither of you two can be an 8. We kind of knew that. In this region, we're missing some numbers. We're missing the numbers 8 and 9. You need to be a 9. You need to be big boy 9, and you need to be big boy 8. That means you need to be an 8, and you need to be a 1. All right, the rows. In this row, we're missing a 3. That 3 needs to go out here. We're also missing a 6. That 6 needs to go here. In this region, we're missing 3 numbers, and I think this row is going to help us fill those in. 1, 2, 3. We are missing a 6, a 7, and an 8. This needs to be a 6 and 7. You need to be an 8. You need to be 6 and 7. Here we're missing some numbers. Maybe I should think about this column first. What are we missing in this column? We've got a 1, 2, 3, 4. We're missing a 5. There's only one place the 5 can go. What else are we missing? We're missing a 7. There's only one place the 7 can go. So you need to be a 7. You need to be a 5. And now in this row, we're missing some numbers. What are we missing in this row? We're missing a 4. Don't know where it goes. We're missing a 7. And we know where that goes. The 7 needs to go here. I guess we're not missing a 7 after all. What are we missing? We're missing a 9, and the 9 needs to go here. You need to be a 9, and you need to be a 4. All right, making some progress. These numbers seem like they would be attainable. 1, 2, 3, 4. We're missing a 5 and a 9. But I don't know what I don't think. This little row, we're missing a 2 and a 6. Am I right about this? You need to be a 2 and you need to be a 6. Now you need to be a 7. You need to be a 7 is what I said, and you need to be a 6. Now in this column, we're missing some numbers. We're definitely missing a 3. I think that 3 needs to go down here. What are we missing up top? We're missing an 8. Now we've got just one cell left. Coincidentally, the number that is missing is 1. And now down here, we are missing the numbers. I'll just kind of put them in. 4, we're missing a 7 and a 9. The 9 needs to go down here. But the 4 and the 7, I think, could go in either of these. The other one there is a 7. Up here, we're definitely missing a 2. That 2 needs to go here. We're also definitely missing a 6. 6 needs to go up there. Down here, we're missing some numbers in this column. 1, 2, 3, 4. We don't have 4, do we? You need to be a 4. And I think that's going to illuminate everything, but 1, 2, 3, 4, 5, 6, 7 is the other missing mystery number. Now you need to be a 7, which means you need to be a 4. You need to be a 4, 7. You need to be a 3, which means you need to be a 7. And now all we've got left is this row. These 3 rows, 1, 2, 3 is my missing mystery number. 6 is the missing mystery number down here, and then the last one here is 5. Well, it looks good as far as they can tell, although the puzzle doesn't include a solution. That was a fun one, Willpower. I'm going to have to check my own solution to make sure it is correct, but I did like this puzzle, and I am proud to be the 134th solver. I guess some people have solved it before I have. You're in the last, 36 minutes and 7 seconds. But that was a lot of fun. Great way to spend a morning over coffee. And thank you for watching. I hope to do more puzzles soon.